In this part of the book, we're going to talk about the dependence of rate on concentration. So we know that if we change the concentration, the rate of reaction is different. Here is a figure from the textbook. It shows the fact that this one has a higher concentration, so this is basically the same mass of the two compounds are here, but this one has a smaller volume than this one. So this is a higher concentration and a lower concentration. After 20 seconds, the solution on the left that was higher concentration has already changed colors, okay? And the solution on the right changes after 40 seconds. So obviously the higher the concentration, typically the faster the reaction goes. Not always, but most typically. The way that we're going to express this is something called a rate law. A rate law is simply an equation that relates the rate of the reaction to the concentrations of any reactants and or catalyst that may be present raised to various powers. And then we're going to have a proportionality constant, which is basically just a proportionality constant is what allows you to, a factor, if you will, to convert between the concentrations and the rate. And then we're going to call that the rate constant. So for the generic reaction of A plus B plus with the catalyst present goes to form D and E, and now the lowercase are the coefficients there. The rate law for this is that the rate of reaction is equal to K, which is the rate constant, times the concentration of A raised to the M, the concentration of B raised to the N, and the concentration of C raised to the P. Now, as I said, A, B, D, E are the stoichiometric coefficients, but you'll notice that they do not appear in the rate law equation. C is the catalyst. Like I said, K is the rate constant. You have to find that experimentally. And then these M, N, and P are what we call order of the reactant. They also have to be determined experimentally. I can't look at a chemical equation and get what the rate law is. Okay? I have to do an experiment to find that out. Now that M, N, and P that we had in the previous slide, and we skip O because O looks like 0, so we go M, N, and P. Different textbooks assign different variables for this. Some will say X, Y, Z. Most will not say A, B, C because of the generic equations A, B, C. The textbook we're using goes to the middle of the alphabet of A, M, and P. And so these exponents are what they call a reaction order, okay? And then the overall order is just where I sum up. So from the previous slide, these right here are the M, N, and P. And then the overall is M plus N plus P. Okay? So for the reaction of nitrogen monoxide, NO, plus chlorine gas goes to form NCO. Okay. This is a coincidence. Our textbook does this a lot, and I don't like it because I just said that the fact this is 2 and this is 1 has nothing to do with this, and that's still true. So I would rather they pick examples that that's not true. But, okay, going to answer the question. It wants to know what is the reaction order with respect to the nitrogen monoxide. And the answer is 2. And it came from this right here. So basically just asking what is the exponent there. Let me change colors. What is the order with respect to chlorine? Nothing written there is understood to be 1, so this is equal to 1. And lastly, what is the overall reaction order? 2 plus 1 gives me 3, and so that's the answer to that. Okay, so when given a rate law, the reaction orders are simply the exponents. If there's nothing written there, it's assumed to be 1. And then the overall order is assumed to be 3. Okay. Now, we're going to be determining the rate law in the following videos, okay, from the concentrations and the rates. We're going to use one set of data. But basically, if the concentration of the reactant is doubled and the corresponding, so the concentration of, let's say, A is 0.2, and then we double the concentration to 0.4, but the rate goes from being 2 to the rate going to be 8, okay? then basically what happened is that this doubled. Okay, so the factor of A, let's say A1 and A2, rate 1 and rate 2. So 2 divided by the concentration of A for 1 was equal to 0.4 divided by 0.2, and that doubled, versus the rate for 2 over the rate for 4 is 8 divided by 2 gives me 4. Okay. Then 2 raised to what power is going to equal 4? And x is going to be equal to 2. So therefore, the order with respect is going to be 2. Okay? And that's what we're going to be doing in the next couple